I am Khaled, a software engineer at Google in Cloud Composer team. Thanks for attending today. I'll be talking about building airflow setups which are resilient to zonal or regional down events and disaster recovery. This topic is related to all airflow versions, including the newly Airflow 3. Let me go through the agenda that I'll be talking about today. So first, I'll be talking about the resilience problem. What is it and how is it happening? We'll be talking about the triggers of this problem. And then we will be going through all the mitigation strategies that are crucial to be implemented to resolve those triggers. And then we will have some conclusions, and there will be some time for Q&A. So let's first talk about the problem. The problem is that you are using Airflow as a solution for your business. Let's assume that you did the software without any bugs, everything is working perfectly, but there is always something that is easy to miss, that what if like the computing power that you have is having some power outage? What if there is some network outage that is happening that will cause all the fully functional software to fail? So the software behavior during these outages can be affected in multiple ways. We will separate them into two separate aspects. The first thing is physically. That's how like the critical components that are being like located as a computing power for the Airflow setup are just fully not working right now. And the second aspect is that, okay, if we have some small hiccups, everything is working, but it stopped working for a couple of seconds, but retries are there, but your DAGs are prone to these failures in which like the retries are not running successfully, or there are some problems happening on how the DAGs are implemented. So the mitigation strategies, we'll be talking about multiple ways on how to solve those. First of all, we should have retries in our tasks, because it's inevitable to recover from like the same attempt in the same task. So we will always talking about how to make your software run on the second attempt of a task. So if you have a task, if and something happen on the second attempt, it should be fully functional and fully working. And it will be separated into two things. First of all, the infrastructure, which is we will separate into 3 points. First, we will talk about deployments replication, and that you should replicate your deployments and critical workloads. And then after replicating those, we need to spread them in a way. And then we will also need to spread our data, which will mainly be the Airflow DB. And the other part will be about the DAG implementation and the analysis that should be done and keep in mind while you are implementing your DAGs, which will be in 3 points. First is statelessness of the DAGs, and idempotency if your DAGs have operations, and also like if your DAGs have external dependencies, we'll talk about the replication of those DAGs dependencies. It's important to mention that those are complementary strategies, so all of them needs to be implemented. If one is missing, it can affect the whole thing. So they are all crucial and necessary. Let's talk about the first strategy, which is the replication of the critical components. First, we'll talk about deployment replication. The Airflow setups are having some critical workloads. For example, the workers, schedulers, if you're using Airflow 3 internal API. Of course, this list can be extended to however you are implementing the Airflow setup and what configuration you're running through. But we are here mentioning examples for the most crucial Airflow setups, which are common for all configurations, for example, workers and schedulers and so on. And how failovers to, like if you implemented those replications, if you have to replicas, for example, as for everything. So if one fails, you will have failover to the healthy replica which is running. And if you replicated the deployments, there is also something that is like the database or the data replication. The main thing is the Airflow DB. This also needs to be replicated. You need to have multiple replicas of the DB runnings in order that the healthy replicas of the deployments will be able to access the states of the tasks and everything at any point of time. Replicating the DBs might be more challenging than the workloads, because the workloads you can specify 2 replicas, for example, if you are using Kubernetes, and it will work all of its own. But there are multiple ways in Postgres, for example, if you are using it, that can be done to introduce replication to your DBs. Or if you are using a cloud solution, for example, Cloud SQL, you can use high available DBs and it will work. So that's the two important things that we will always need to replicate. Also, I'll mention again that it's important for the deployments to be expanded to whatever your Airflow configuration is done. It's different in multiple use cases. The main things should be replicated, and any extra critical components should also be replicated. So, for example, let's assume that you are deploying your Airflow setup locally in some server building, and you have 2 identical rooms. Let's first talk about a term, which is failure domain. What is a failure domain? It's a set of entities or objects or computing power that if anything fails in this failure domain, means that the whole domain is like not working now. For example, they share the same infrastructure. So if there is some power down, the whole failure domain is down. So here in this case, let's assume that we have 2 rooms. There are the 2 failure domains. First contains replicas for schedulers, DB, worker, internal API. We're using only those as if they are the only critical components in our setup. And in the other room, we are having the second replica of the scheduler, DB, and the work in Airflow 3, and the internal API if you're using Airflow 3. We have 1 or 2 which is not consistent in the rooms. It's just to indicate that it doesn't have to be like the main replicas of everything should be in the same room and the failover replicas should be in the other room. It doesn't matter. You should have 2 replicas running anywhere, and the failover will happen to the healthy one, which either the main is still working or the secondary is the one that will be failed over to. And now the first room loses the power. There is a power outage. So what will happen now? Let's pick the 3 components, which is like worker and scheduler and the DB. So in a normal situation, like the scheduler is reading the state from the DB, it finds out that I need to schedule a task. I will schedule it on some worker replica. I will pick one. And the worker is now running the task. It will not write its state to the DB that it's done until it's fully functional. But we have a power outage and the task is failing in the middle, nowhere to be found. And then after the outage, the scheduler checks the other replica of the DB. So it's there, it's being able to check it. The other replica of the DB says that this task is being scheduled but never ended. So the scheduler will decide, okay, I will do the second attempt on the healthy worker that is running, and the worker will pick it and will finish it up. And here because of the replication, we are still having some continuity of the task, which means continuity of business. But what if the 2 rooms are sharing some bigger infrastructure? Now the 2 rooms are becoming 1 failure domain, not 2. So that brings us to the second part, which is how you could think of spreading those replicas. It might be different on the scale of your configuration or the use case, but you should be able to define what are the critical infrastructure that you are not wanting anything to be prone to, and separating this into 2 failure domains. So for example, if for your use case you decide, okay, I will assume that the LAN cable that goes connecting to the room X is the infrastructure, so I will assume that this is the all failure domain. I will put all the replicas there and all the other replicas in the other failure domain. You can also have multiple replicas, 3, 4. It really depends on the use case or what you are doing. Or for example, if you're using Kubernetes, if it's locally or in a cloud solution or a cloud provider, there is a way that you can spread the replicas of the the replicas across zones of Kubernetes if you're using a cloud solution using this. So in this case, every building, for example, we assume that we will separate the replicas into two different buildings. Now the whole building is the new failure domain. So if the whole building is losing the power, the previously named room A and B are just like having one failure domain, and the other will be working, which means that the other building and the other replicas will be picking the tasks, and it will be continued. The other part will be, okay, we did the replication and then the spread of the replicas, and our DAGs are doing the retries, but what if the behavior of the DAGs are not capable of doing retries successfully? This can happen because of many factors. Three of the main things are having stateless DAGs. This will help. If you're having stateful DAGs, it will be a problem. We'll be talking about this. Also, if you are doing operation within your DAGs, they have to be idempotent, and if you are having external dependencies, they need to be replicated as well as the critical components. So let's go through each one independently. So stateless DAGs, what is stateful and what is stateless, because it's a very broad term. So here, our entity that we are talking about is a DAG running in a worker. So what makes it stateful? If the current state of the DAG is being reserved in an ongoing session, which is a worker running. So, for example, if we are having a task that runs, it is having state during the whole runtime, but it's saving the state locally within the worker, and then it falls midway, and then the other replica which is failed over is picking this task. It's picking the task on the retry, but fetching the state to know where we are. Now it doesn't see anything that is being written locally because it's a different instance of the worker, and there will be inconsistent state. So for example, the first one did ABC, but now it doesn't know anything, so it will be starting all over again because the state is being reserved locally, so the DAG running in a worker is now stateful. So that will be causing losing of the progress that is being done. Also some inconsistent states on retries, which means that during the failover there will be like issues and it will not be done successfully. But if you are having a stateless task, for example, in the previous case, we are saving the state on an external DB, or we are using a GCS bucket, for example. Now the state is always away from the DAG running on a worker, so a DAG running on a worker is now stateless. So if it falls midway and the other worker picks it, it will be able to read it from the GCS, and it will be continuing from exactly where it stopped, and it will finish it successfully. The other thing, if your DAG is having like some operations, for example, let's assume that your DAG does some logic, and then midway it appends something to some DB, and then does some extra logic, and then it's finishing. So if it falls between, like it already did the logic and then it added some rows to the DB, and then it falls before it fails before it's done successfully. So on the next run, it will not know that it already like added it to the DB, so it will start the operation again, but it will not figure out that it added to the DB, so it's writing again. So doing the operation multiple times will result in different outputs. That's what idempotence is that if you run the operation multiple times on the same thing, it will produce the same output. For example, this can be fixed if your operation has this step, which is writing to the DB, implemented in a way that it's, okay, if it's already written to the DB, don't write it, else write it. So this will make the operation, even if you run it like a million times, it will only write once. So that makes the operation idempotent, which helps like in preventing like duplicate steps in the same operation, and also like simplified recovery after those failures. So in a good scenario, which we have like replicas, it will run the operation. Now it won't write to the DB again, and then it will continue successfully. The last thing is that introducing some things that we did, for example, in introducing the GCS bucket where we save the state. Now we are having some external dependency for the DAG, which can become the single point of failure. So it's exactly the same as the critical components of airflow setup. So it also falls in the same methodologies of replicating and spreading those replicas. So now it becomes a critical component of your airflow configuration, even if it's not like critical for just airflow running, but it's because of how your DAGs are implemented. It's now part of your like critical components that is being run. So, and DAGs often depends on like external GCS, external dependencies, or for example, you are calling some services that exists regionally or stuff like this. So it's crucial to make some analysis to the DAGs and classify which dependencies are like crucial for the DAGs and also replicate them and use the same spreading of replication that we talked about. So for example, in this GCS thing that we were talking about, if now everything is replicated, but this bucket is not available for some reason, then it will have the same exact problem of not being able to retrieve the state, and now it will also fail. So for example, if you are having some cloud solution like Cloud SQL, so the cloud, you can use some high availability bucket or something. So in Cloud Composer, we faced those problems a lot, and we decided that we were implementing a feature which is high resilience. So in Cloud Composer, you can create your environment in high resilience mode. And this high resilience mode, you will have some requirements when you pick it up, and it will show errors and will not be created unless you have like the number of replicas that are needed to create the resilient infrastructure. And it automatically handles the infrastructures with the methodologies that we were talking about in this talk. And you can play around with this if you want. You can create a Cloud Composer, just pick high resilience, and it will do all of this. But you will still, as we said, make analysis to your DAGs that, okay, the infrastructure is handled automatically by Cloud Composer, but you need to have your DAGs analysis correctly, so it's good on retries, because we guarantee that it's going to happen, the retries, but not the like having the correct output if your DAG is having some external dependencies or calling some external services away. So the conclusions is that if availability is crucial for your business, replication and spread are crucial for your critical components, you also need to make some analysis to your already implemented DAGs or the next ones, and make sure that they are stateless, high idempotent, and so on and so forth. And it's also worth to mention that resilience comes with a trade-off. So having 2, 3, 4 replicas will introduce more cost, which is also introducing more complexity to your infrastructure and more complexity to your DAGs. And sometimes, for example, as we have seen that if you have 3, 4 schedulers, it might introduce some latency. But still, it's more of a trade-off, whether your use case is really crucial to have this availability of, or if you are okay with the drawbacks of cost and complexity and having some bit of extra latency. And also, it's also worth to mention that this thing can like scale a lot. So if for example, you are defining your failure domains as buildings, you can make your setup prone to buildings problems. But what if it's cities? What if it's continents? It always scales it scales bigger, and sometimes it becomes inevitable, but you try as much as possible as your use case to avoid any common things that might happen. So that's it. You will find my email if you want to talk in detail about something.